Hey, welcome. Today, we're going to talk about a crisis you probably never even knew happened. A moment in the 90s when the internet almost just stopped growing. It's a really cool story about running out of room and the clever fix that, honestly, keeps us all online today. So let's just jump right in with the big question. The internet was exploding, right? It was getting super popular, but it was heading straight for a brick wall. It was literally, and I mean literally, running out of addresses. So how did we fix it? What saved the day? Well, let's get into it. So the heart of the problem was pretty simple, actually. The internet was growing way faster than its original address book could handle. Try to picture a brand new city where thousands of people are moving in every single day. The problem is you've only got three sizes of land to sell them: small, huge, and impossibly gigantic. You can probably see how that's just a recipe for disaster. Okay, so let's dig into that first system and see how things used to work. It was called classful addressing. And, when the internet was tiny, it kind of made sense. But that rigid structure, that was about to become its biggest problem. You can really think of classful addressing as the internet's first draft of an address book. Super simple. It basically took every single IP address possible and just chopped them up into 5 fixed size groups or classes. It was a logical first step, kind of like a city planner saying, look, you can have a small plot of land, a medium one, or a large one. That's it. No other sizes available. And this table, wow, this is where you can really see the problem. Just look at these numbers. A small company might get a Class C network with 254 addresses. Okay, fine. But what if they needed just a few more? Well, the very next step up, Class B, wasn't a small jump. It was a leap to over 65,000 IPs. And Class A, we're talking more than 16 million addresses. There was just no middle ground. And because of that rigidity, you get the system's absolute fatal flaw: massive, unbelievable waste. The jumps between the class sizes were just so huge. This inefficiency wasn't just a small issue. It was a ticking time bomb right at the heart of the early internet. This chart just shows it so perfectly. Let's say your company needs about 5,000 IP addresses. Under the old rules, you were forced to take a whole Class A block. That means you get almost 17 million addresses. It's like needing a small cottage but being forced to buy an entire country estate. The result? Millions and millions of addresses were just sitting there, completely unused and locked away so no one else could have them. So, with the internet speeding towards this address crisis, a hero shows up in 1993. It was this really elegant, super flexible solution called classless interdomain routing, or, as pretty much everyone calls it, CIDR. So what did CIDR do? Well, it basically just threw that whole rigid class system right out the window. Instead of these big, clunky, fixed blocks, it introduced a brilliant method that lets you create a network of exactly the size you need, no more, no less. It's like going back to that city planner and saying, hey, I need a plot of land that's exactly 53 square meters, and then being able to just give it to you. All that waste, gone. Now, when you first see this CIDR notation, it can look a little technical, right? But it's actually super straightforward. You've just got 3 parts. First, the network address itself, then the slash, and finally, the prefix length. And that little number after the slash, well, that's where all the magic happens. And it really is the magic number. Seriously, that single number is the key that unlocks all of CIDR's flexibility. It gives network admins the power to carve out a chunk of the internet that is perfectly sized for what they need. And here's how it works in the real world. A /24 gives you 254 addresses, pretty standard. But what if you only need, say, 60? No problem, you can use a /26. What if you just need a couple? A /30 has you covered. It's all about total control and total efficiency. So let's just put these two systems side by side, because when you see them head to head, the difference is, well, it's like night and day. I mean, this slide says it all, doesn't it? On one side, you have the old way, rigid, wasteful, complicated, and on the other side, you have CIDR, flexible, efficient, and so much smarter. This wasn't just a minor update. It was a complete reinvention of how the internet works. So this is the really crucial part. Why are we talking about this now? Why does some super technical change from over 30 years ago still matter so much for how the internet works for you and me right now, today? Because here's the bottom line. Without CIDR, the internet as we know it today just wouldn't exist. It couldn't have grown to this massive scale. It stopped us from wasting all the available IP addresses. It made sending information across the globe way simpler and faster, and it created the flexible foundation we needed to connect, well, not just a few thousand computers, but billions and billions of devices. And yeah, it all goes back to that one pivotal year, 1993. It is just amazing to think that this critical innovation that we all completely depend on every single day was put in place so early on. It solved a crisis before most of us even really knew what the internet was.
So we'll leave you with this final thought. CIDR was the brilliant, elegant solution that saved the internet from its first huge scaling problem. But now, as we're connecting trillions more devices, everything from our watches to our refrigerators, what do you think the next great addressing challenge is going to be? Thanks for tuning in.